Hello students, in this video we will discuss solution of homogeneous linear differential equations with constant coefficients. A homogeneous linear differential equation will look like this. This is homogeneous because its right side is 0 and constant coefficients means all these pi's are constants. Now the method is, first of all, we put dy by dx as capital D and corresponding second derivative d square upon dx square as capital D square and so on. So this will be transformed to this form. Then we solve this auxiliary equation for the roots. Now depending upon the roots, if we have one real root, then solution may be written as c1 e power m1x, and if we have two real roots, solution may be written as in the similar way c1 e power m1x plus second c2 e power m2x. And if we have a complex roots alpha plus minus iota beta, then alpha real part, beta imaginary part, then solution may be written as e power alpha x bracket c1 cos beta x plus c2 sin beta x. This is how we solve this equation. Let us try some numerical based on this method. Let the first numerical be d square y upon dx square minus 11 dy by dx plus 30y. So first of all, as we discussed, we transform this equation. That is, this may be written as capital D square minus 11d plus 30 times y is equal to 0. So very easily we just have transformed d by dx as capital D and d square by dx square as capital D square. Now we solve this auxiliary equation. So the auxiliary equation is capital D square minus 11d plus 30 is equal to 0. So very easily we can factorize this. That is minus 6d minus 5d plus 30. That is, if you add this, this is minus 11d. When you multiply this, this is plus 30d square. So taking d common here, d minus 6 and minus 5 common here, d minus 6, which may further be written as d minus 5 into d minus 6 is equal to 0, and the roots are 5 and 6. So we have two real roots. So the complete solution is y is equal to c1 e power 5x plus c2 e power 6x, where c1 and c2 are constants. So this is how we can solve this type of numerical. Okay, let us have one more numerical. Number 2, let it be d square y upon dx square plus 3dy upon dx minus 40y. So very easily, as we discussed here, we transform this. This may be written as capital D square plus 3d minus 40 times y equal to 0. Therefore, auxiliary equation is d square plus 3d minus 40 equal to 0. So we solve this equation for its roots, and we can easily factorize this by writing 8d minus 5d minus 40. So here we get 3d, and when we multiply we get minus 40d square. So taking d common, d plus 8, and taking minus 5 common, again we have d plus 8. So the factors are d minus 5, d plus 8. So from this, very easily, what are the roots? 5 and 8. So solution is y is equal to, again using the same formula, c1 e power 5x plus c2 e power 8x. Again, where c1 and c2 are constants. So this is how we make use of that formula. Another numerical, that is solve d square plus 1 cube, and here we have d square plus d plus 1 square, y is equal to 0. So here we are already in the terms of capital D. So we directly write auxiliary equation is d square plus 1 cube and d square plus d plus 1 square is equal to 0. So we solve these for the roots. So as you see, product of these two is equal to 0. This implies d square plus 1 is equal to 0. D square plus 1 is equal to 0. D square plus 1 is equal to 0, as well as d square plus d plus 1 is equal to 0 and d square plus d plus 1 is equal to 0, because we have 3 factors from here and 2 factors from here. And very easily we can write the roots from here. You can see d square plus 1 is equal to 0 means d is equal to minus 1. So what is d then? D is plus minus iota. And how many times this will appear? 3 times. Plus minus iota and plus minus iota. And from here, very easily, we can solve this by discriminant method. So what will be d then? So d will come out. Then d will come out minus 1 plus minus under the root b square means 1 minus 4, that is minus 3 upon 2. And that can be written as minus 1 by 2 plus minus iota root 3 by 2. And it will appear twice. Minus 1 by 2 plus minus iota root 3 by 2. So how many solutions we have? We have 3 pairs of complex roots here and 2 pairs of complex roots here. Okay, so based on the formula, let us write the solution. Solution will look like, here as you see, a real part is 0 and we only have imaginary part. And how much is the imaginary part? 1. Don't confuse with iota. Here the imaginary part is 1. So we don't have any power of e because it's already 0. So in the bracket we have c1 plus c2x plus c3x square cos of x plus c4 plus c5x c6x square sine of x. So this part we get from this. Now we write solution for this part. We write plus here and e power. So how much is real part? Minus 1 by 2. And we have this solution twice. So after c6 we have c7 plus c8x and imaginary part is root 3 by 2 cos root 3 by 2x. So here also we have x plus c9 plus c10x sine root 3 by 2 x. So this is the solution here. I hope this is clear to all of you how we have calculated roots, and because same root appears thrice, so this is the way how we express this answer. Another numerical, that is solve d power 4y upon dx power 4 plus m power 4y is equal to 0 for m strictly greater than 0. So first of all, we will express this in terms of capital D plus m power 4 times y is equal to 0. Let us solve this for the roots of this equation. For that, we use a method. We will add 2m square d square m power 4 and we subtract the same term m square d square. And as you see, when we combine these terms, so this will appear as a perfect square, d square plus m square whole square. And also this may be written as perfect square for which under root 2 m capital D whole square, and which is a formula a square minus b square. Let us expand this. D square plus m square plus root 2 md and d square plus m square minus root 2 md equals to 0. Now from these factors, very easily we can write that d square plus m square plus root 2 md is 0, and also d square plus m square minus root 2 md is 0. So which can be solved using discriminant method. Then how much is capital D here? It will be, so this is minus root 2m plus minus under the root 2m square minus 4m square upon 2. And also here we have minus root 2m plus minus under the root 2m square minus 4m square upon 2, which can further be simplified that capital D will become, so here we have minus 2m square, so m can be written outside, and for minus we can write iota. So let us simplify this further. Under root 2m plus minus iota under root 2m upon 2, and here also we have minus root 2m plus minus iota root 2m upon 2. So very easily we can take under root 2 common, and this may be written as under root 2 square. So one under root will cancel. So we have d is equal to m by root 2 plus minus m by root 2 iota, and here minus m by root 2 plus minus m by root 2 iota. Then the solution may be written as, based on these solutions, these are roots, solution will look like real part e power m by root 2x c1 cos m by root 2x plus c2 sine m by root 2x plus, now real part is this, e power minus m by root 2x c3 cos m by root 2x plus c4 sine m by root 2x. So this will be the solution here.